I'm the CTO of .cms, and I wanted to share with you the new cluster wiring framework that's been built into .cms 2106. Just a quick demonstration of how it works. So what I have here is a single .cms instance running, and this is running in Kubernetes, running in EKS and in Amazon's Kubernetes. And you can see here, if I come to the networking tab, which is familiar for anyone running .cms clusters, which will tell you the health of the cluster, you can see the cache transport here has been updated to pub/sub, and this is the new cache transport and cluster wiring code that's been built into .cms 2106. And just to give you an example of how it works, I'm going to go ahead and update the Kubernetes installation to, let's say we want to have a cluster of 3 .cms nodes, and I can come and apply that and then watch as those nodes, those pods come up, and you can see them starting to launch here. And before 2106, .cms had used Hazelcast to do our clustering. The issue was that Hazelcast was embedded in .cms and that it caused hiccups whenever the Hazelcast started to wire itself, and scaling up and down using that embedded Hazelcast inevitably caused issues with the cluster and the cluster health. But you can see here now, if I come to the licensing tab, you can see here that now we have 3 servers that are coming online, and if I watch, they've been running for roughly 30 seconds. And I can come to the network tab, and you can see now those have been wired. They have licenses, and they're all part of the current cluster. And there hasn't been any hiccups or any sort of service delivery. It just scales up and down as you change the number of replicas. So here, let me say, let's go to 6, for example, and we can apply that, and then watch those pods come up. And it does take, if you take a look, you can see here we have a ton of licenses. .cms has a site license, so shouldn't be any issue for site license holders to have enough licenses available in order to scale up and down. And as the servers come online, they'll pick up. You can see here they're starting to pick up those licenses, and the network's wiring itself. So now we have 5 servers, 19 seconds while .cms fires up. Now we have 6 servers. And this can go on and on with the pub/sub framework using the Postgres listen notify pub/sub. We can increase this number up to 10, up to 20 nodes. And so it's just, let's bump this up to 10 here, and it scales up smoothly. Again, based upon your Kubernetes deployment. Right. So let's see how many servers we have now. We have 8 coming online. Let's see, here we go. Now we have 9. Right. And so now we have 10 servers. And you can see here these servers are all licensed and all part of the .cms cluster in order to deliver content, at scale. Taking a look at our pods here, we have 10 pods, and scaling down is just as easy, right? So we can change these replicas now to 3 and deploy that. And we can watch those get terminated. we come to our network tab, and the terminated, you can see here the terminated pods are going to go red. There's a delay when the server gets terminated and when that license gets released. It's configurable, so it's set to 4 minutes. So the cluster will wait for that server to potentially come back online for 4 minutes, and then after that it'll free the license. And so you can see here the cluster scaling down. Now we have 3 nodes in our cluster. You can see these other nodes have been terminated, right? And we can even scale down to 1 node. So the scaling in .cms 2106 in the cluster wiring is much smoother and really, enables you to run, clusters of .cms that can scale up and down without, based on the traffic demands and without any sort of hiccup or problem with the cluster wiring itself. Thank you, everyone.